friends. Welcome in ADSUL'S Technical Campus, Faculty of Engineering and MBA, CAS, Ahmednagar. Today in Power Electronics, myself Professor Jyoti Thange explaining the new one point, that is switching characteristics of SCR. Give the heading, that is switching characteristics of SCR. These switching characteristics of SCR classified into two, that is turn on characteristics and turn off characteristics. First one is turn on characteristics and second one is turn off characteristics. Now see one by one. First of all, we learn turn on characteristics. I will draw the graph for turn on characteristics. Here, gate pulse is there. Then anode current. Next one is voltage between anode to cathode. Now here, this is the time t is equal to 0. After that, this is t1. We can say that t is equal to 0 means t0. This is t1, then t2, and here t3. Same will follow for this, that is t0, t1, t2, t3, t0, t1, t2, t3. Here your SCR gate turn on. SCR gate turn on, and before this your SCR initially in off condition. Now this is the time required to turn on the SCR. This time is also called as, this is also called as TD. This time
be shown by different friends so that you can easily identify. This is a delay time, this is a rise time, and third one is TPS, that is plasma spread time. These are the characteristics called as a turn on characteristics of SCR. Now I will explain one by one. First of all, see here SCR is turned on by applying the gate pulse. This is the basic thing. To turn on the SCR, gate pulse is necessary because before lecture we learned that turn on methods and gate pulse, applying gate pulse means gate triggering is the most significant or practically used method to turn on the SCR. Hence it is very necessary that we should apply the gate pulse to turn on the SCR. Now see here, this gate pulse is start from this timing called as a t is equal to 0. At this time gate pulse start. Now when we apply the gate pulse, it should have the specific magnitude and it should have the specific duration, because to start the SCR we need that gate pulse should have the specific magnitude as well as duration. Now this gate current is applied at t is equal to 0 as shown in figure. Now this waveform from anode to cathode current as well as voltage, that is current waveform called as anode current, voltage waveform that is the VAK voltage between anode to cathode is shown in figure. Now to turn on the SCR we observe that from this timing, before this SCR is totally in off condition. After that it starts to turn on and to completely turn on at T3 timing, means at this point SCR gets totally in on condition. Now from this timing to this timing, this is the time required to turn on the SCR. Means we can say that turn on time, that is T on time, is nothing but it will start from this point called as a t is equal to 0, because gate pulse actually applied at this point. Hence your SCR turn on time is actually start from this point. Hence t on time is equal to TD, that is delay time, plus TR, that is rise time, plus TPS, that is a plasma spread time. And after this interval your SCR completely goes in on condition. This is the time required to turn on the SCR. Now what is mean by delay time, what is mean by rise time, and what is mean by plasma spread time? See one by one. First is turn on delay time. First is, I will write here, turn on delay time. Turn on delay time. Now see what is mean by turn on delay time. During this time SCR is in off state and the voltage across SCR remains constant and high. You can observe here, during this time TD time your current is constant and voltage is very high. Current is 0. But the gate current is already applied here. But gate current is applied here and excess carriers are injected into the P2 layer. P2 layer means which layer? Where we connecting the gate terminal. This is the P2 layer. At the end of this interval, the voltage across SCR begins to reduce and the anode current start increasing. You can see here. Your current start increasing, voltage start decreasing in this interval. Now second one is, that is rise time. Second is rise time, and this rise time is denoted by TR. Now observe here, after this TD interval, that is the delay time interval, from this point your current start increasing and voltage start decreasing. This is called as a rise time. In this rise time, actually your current start increasing and voltage remains constant. Voltage start decreasing. Voltage start decreasing, but its decreasing period is not that much. Now, at this rise time interval, during this rise time interval, you finally anode current goes into its constant value as shown in figure. After this interval, ending of this interval, your rise time, your anode current becomes constant and your voltage still going on decreasing. Observe here, after this point also your voltage goes on decreasing, and this time, that is current is constant but your voltage goes on decreasing. This is called as a plasma spread time. That is the third time, plasma spread time. In this time, your current is constant but voltage still going on decreasing. And at the end of this plasma spread time, your voltage is become very low, approximately or ideally it will be 0, practically having very small value, and your current is very high, having the constant high value. Means anode current is high and voltage between anode to cathode is low. Means we can say that in this case your SCR goes in completely on condition. This characteristic is called as a turn on characteristics of SCR. Now, second point is turn off characteristics of SCR. Second point is turn off characteristics of SCR. Now, see the diagram for that. Now, see, these are the turn off characteristics of SCR, and this turn off characteristics is drawn for anode current and voltage between anode to cathode. Now, see, what is the condition of turn on? The condition of turn on is that anode current should be high and voltage should be low. This is your turn on condition. Now, observe here anode current is very high and voltage is small. Means here before that your SCR is in on condition, totally in on condition. And when we observe here your anode current is 0, becomes 0, and voltage becomes high. Here your voltage becomes high, means this is a totally off condition. After that, this is a totally off condition. Before this means your actually turn off time is the time start from when it goes in off condition. Here it is totally on and here it is totally off. Between this time, this is the time required to turn off the SCR, and this time is nothing but this TRR, addition of TRR plus TRC. This TRR is called as a reverse recovery time, and this TRC is called as a reverse recombination time, or only we can say that it is a recombination time. Means your total turn off time is the addition of, here below given turn off time is the addition of reverse recovery time plus recombination time. Now see, what is reverse recovery time and what is recombination time. See, first is reverse recovery time. First is reverse recovery time. In this, the device manufacturers specify a turn off time. Means your total turn off time is decided by manufacturer only, or it is pre-decided for different SCR, which represent the minimum time of SCR should remain in the reverse blocking mode before any forward voltage is revamped. That means for successful commutation or successful turn off of SCR, it is necessary to reverse bias the SCR for a period of or equal than TQ because before applying the forward voltage. Because without that, it may be accidentally turned off. To avoid this, turn off time, that is TQ, is the sum of reverse recovery time plus recombination time. Now see, the turn off time of SCR is totally dependent on current flow through the SCR. Then second one is rate of decreasing current, that is di by dt. Third one is its junction temperature, because in SCR there are 3 junctions present, J1, J2 and J3. How much temperature of junction is present. Then next one is magnitude of reverse voltage. These are your total time, reverse recovery time. Now the reverse recovery time, what happens? Check once again. In this reverse recovery time, your anode current goes on decreasing, and after crossing 0 point, it also goes on negative side. Why? Because when your electron hole pair get recovered in this case, after this 0, maybe electron hole pair get increased and it may increase your anode current. To avoid this, it is necessary to become the charge equal to 0. Hence, it first of all it goes to negative side, and when your total charge get removed, at that time it again goes to 0 level. Same will happen for the voltage. This voltage goes on decreasing, and after the crossing of this, your total voltage should be high, and this is not happen when we decrease this voltage and it goes below this, means your recombination goes on decreasing. Recombination of electron and hole goes on decreasing. It becomes totally 0, and after that it gets increased, means your voltage is now at high level. In this way, your turn off time of SCR is the addition of TRR plus TRC. Now here T of time means circuit turn off time and your SCR turn off time are totally different. But this is the important concept at the time of turn off the SCR. Your only SCR turn off is not necessary, but we have to completely turn off the circuit also. Hence your circuit turn off time is always higher than the SCR turn off time. And when your circuit is completely off, then and then only there is no possibility to turn on the SCR. Hence it is necessary to turn off SCR. First of all, we have to take the care of to complete turn of the SCR, turn of the circuits. Okay, thank you.